identify an SCE. So I've been able to put a flowchart together this morning to be able to walk you through in a few minutes how I determine an SCE. Note, every organization have a flowchart, or some don't even have a flowchart. They just adopt a flowchart on how they determine what an SCE is. So the first question I always ask myself is a catastrophic release from the element leading to a high She risk credible? If the answer is yes, we know it is safety critical. On the left-hand side, does the element contain flammable hydrocarbon or hazardous chemical? If the answer is yes, can those chemicals or those flammable hydrocarbon cause a high or catastrophic She event? If the answer is yes, it is safety critical. If it is no, if we go down to no, we know it is not safety critical. Now, on the left-hand side, if I go to the left-hand side, I say, okay, is the element part of a control? Is it a shutdown function? Is it an alarm? Or is it a mitigation system? If the answer is yes, the next question you want to ask is the element designed to provide one of these functions during emergency? If the answer is yes, that element or that device is safety critical. Now, if you go back to the left-hand side, again, to ask the question, is the element part of a control, still a shutdown, alarm, or a mitigation system? And if it's a no, the next question is, could the failure cause an event requiring catastrophic release from downstream or upstream? This event identified during PHA, HAZOP, HAZID, or other risk assessment, and they are inherently catastrophic incident. If the answer is yes, is upstream or downstream equipment designed to withstand this event? Again, design integrity. If it is designed to withstand that event, it is not a safety critical equipment or element. Remember that if you have a vessel designed to withstand your highest pressure, your vessel may be safety critical, but that event, everything is not safety critical. So what I always tell people is that if you have a vessel, ideally a pressure vessel may be safety critical, but it's not a safety critical device. The task in maintaining that vessel, it is what is safety critical, not the vessel. The vessel is not a safety critical device. It is the task in maintaining that vessel that is safety critical. The next one is, if you go down after that one, number 4, could failure of the element cause a major accident event, or does the element prevent, control, or mitigate a major accident hazard? If the answer is yes, it is a safety critical equipment or element. Then the last question, if the answer is no, does the element prevent harm to people in the event of a major accident hazard? If that element is providing a function to prevent harm to people, it is a safety critical element or an equipment or a device, however you want to call it. But if it is not safety critical. In my role when I was in the Middle East, acting as a manager for Qatar Petrochemical, one of the questions people always ask is that, must everything be safety critical, especially when we know that we are producing in a plant where we have some hyper compressor that have over 2,500 bar pressure? And my question is, you know what? These are prescriptive equipment, because if they fail, they will cause an unsafe date. So these kind of devices, even though we know that the critical task is what is an SCE, also make that equipment safety critical. So making an equipment, whether a safety critical device or a safety critical task, is dependent on the organization. It is not according to code. Some are according to code like PSVs, but when it comes to pressure vessels, your organization have to decide, is it categorized? Yes, it is safety critical, but is it the device that is safety critical, or is it the critical task used in maintaining that vessel that is safety critical? Now, an example I did was, I first of all go to the HAZOP, and I come back, after the HAZOP, I'll come back to that other slide. So one of the best technique you can use to identify what is safety critical. It's actually the HAZOP. And that's why when we do HAZOP, we always talk about what excellent looks like. You know, when you want to employ people to do risk analysis for you, you have to employ a competent facilitator or with a competent scribe sometime, able to document what your risk actually is. Again, if you look at them, I'm going to only focus on example, the cost 1.22. If you look at the cost 1.22, is the failure of a pressure control valve, PCV 1000, malfunctions open during normal operation and malfunction open during pigging, 1.2.3. We saw the cost location there. Looking at the severity of the consequence, it is a fatality based on the client's risk metrics because it's an overpressure of the inlet separator leading to a leak or a rupture, a loss of containment of gas and liquid, a fire and an explosion. And if you look at the risk matrix, looking at the severity column before safeguard, I always tell people when you are choosing an SCE, focus on identifying whether it's a major event that is inherently safe, which is the risk before safeguard. Again, for this one, it's a D, which is for the people. I'm only focusing on people today. I'm not going to focus on environmental. So if you see 1.2.2.1, the severity is a D. And the likelihood, I'm not actually worried about the likelihood because the likelihood is irrelevant for me today. So the severity is a D, but the likelihood is what I am using to reduce the safeguard. So if you look at the two safeguards they have given us today, these two safeguards, the risk before safeguard is a D3 because the likelihood is a 3, the severity is a D. Now, if you look at on the risk matrix, it's showing orange because it's a high risk. Now, if you look at the two safeguards that has been confirmed that they are specific, they are independent, they are auditable, and they are dependable, and you can always say, you know what, these safeguards are robust because they have been adequately designed and they have been adequately tested. They decided to take 2 credit for this. They took a PSV 1000, which is set at the right pressure, size for block flow. You must know your sizing place. And they says it relieves to the flare. All these things would have been done prior to coming to the HAZOP. The process engineer, in addition to a lot of people, the smart engineers would have looked at the design case for the PSV. While the PSV is good, we take 2 credit based on the complete standard. Now, the next safeguard they took was the BPCS, a basic process control trip, PSH 1000, and they took 1 credit for that. Note, in HAZOP, you can only see most of the function-based or consequence-based SCEs. Sometimes you can see prescriptive, but if you don't dig deeper, having an SCE standard, the safety critical equipment standard, you would not remember that your V100, which is the inlet separator, which is the pressure vessel, you will not remember is an SCE. The only thing that saves a lot of people is because it's under code and regulation. And that is, again, standard code and regulation is element 2 on CSA 767-17. That's why it's also a must read if you want to understand process safety. Now, you can see all the SCEs there. Once this has been designated as an SCE, you can go back to your PNID. And on the PNID, you can mark this up for your operators. These are the things we use to train operators because if the engineers know about process safety and they know about safety critical equipment, if the operator and other functions don't understand safety critical, believe me, the plant cannot be safe because in process safety, it's collective, not like occupational health and safety, which is individual. So on my PNID today, I've been able to mark for you guys how I look at my safety critical. So if you look at the vessel in itself is an SCE, which I call a PC. SCE PC means it's a process containment. It contains the process. If you look at my 2 PSHH, my PSHH is an SCE. Its function is to shut down. If I look at my level switch, which is also helping me in high level there, its function is to shut down. And if I look at my PSV, which is also in the process containment group, in the 76 SCE I showed you before, its function is to relieve the pressure. So you can see how HAZOP can actually help us to determine what is safety critical. Do you know what your safety critical elements are? Or do you know what are your safety critical equipment? They properly designed? When last were they tested? Can you show me? Show and tell is one of the reasons why our industry can stay safer than yesterday.